Alright class, today we'll talk about using technology to solve normal distribution problems where you have the central limit theorem. So let's get started and you'll see what we're talking about. Okay? Probably shouldn't have done that. Where is it? So here's your first question. Suppose that we would randomly select 64 measurements with a population mean of 20, standard deviation of 4. What's the probability we'll obtain a sample mean greater than 21? Okay, so here what we know is that we don't have the standard normal distribution, so we need to do some norms dist. Okay, norms dist. We know that. I'm sorry, norm dist. We know that our value is 21. We know that our mean is 64. We know that our standard deviation. I'm sorry, our mean is 20. Our standard deviation is 4, and we have true. This would give us the area that's less than it. Well, the first thing we want is the area that's greater than it. So the first thing we have to do is make this 1 minus. And then we have to realize that the 21 is not based on one value, but a sample of 64. So we have to take in consideration the sigma over the square root of n. So it's not just 4, but we'd have 4 divided by the square root of 64, which we know is we all know is 8. Okay? And this will give us our answer. So let's see what we get. So I'm going to copy this. We'll go back to a new data set. Okay? And I'll paste it. So this is 1 minus norm dist. 1 minus means I'm looking for something that's greater than. The average was 20. The average is 20. My sample mean was 21. 4 over the square root of 64 because it's based on 64 numbers. And click true and hit enter. That's fine. And you have 0.0228. 0.0228. So the answer to the question, what percent would do it, is, if I can find your paper, there we go. Nope. There we go. Equal to 0.0228. It's nice to realize if you looked at the z-score here, you'd have 21 minus 20 over 4 over the square root of 64. Well, 4 divided by 8 is 1/2. 21 minus 20 is 1. So 1 divided by 1/2 gives you 2. So this gives you the area that's greater than a z-score of 2, which we said was approximately 2.5%, but it's exactly 2.28%. So that's what this is telling you. The next question, what about less than 19.385? Well, I don't need the 1 minus this time, so I can do norm dist. 19.385. I still have 20 as my mean. I still have 4 divided by square root of 64, and then true. And this will tell me my average is 19.385 or less. And let's see what we get. So we copy this and we put it here, and we'd say equals norm dist 19.385 comma 20 comma 4 divided by square root of 64 comma true. 0.1093. Okay, 0.1093, and we go back to your thing and plug in 0.1093, and that's that. All right, so again, we had to make sure we took in consideration there was 64 samples. All right. Next one. Let's say that we had a normally distributed variable, mean 75, standard deviation 22. What's the probability it will be 80 or larger, assuming our sample is 19? Well, here we need to do the 1 minus thing again, right? Because we're looking at greater than. We still need norm dist. 80 is the number we're looking at. 75 is the mean. Standard deviation is 22. Standard error is 22 divided by the square root of 19, which is our sample size, and true. So when we do that, we get something. Okay. So I'm going to copy this, go back to our page, and go down a little bit. I'll paste it here, and I'll write it here, equals 1 minus norm dist of 80, 75, 22, divided by square root of 19, true. 0.1609. So there's 16% chance, 0.1609. So we're going to put out, back where we were, 0.1609. And you're done. Okay. Next one. If a sample of size 40 is drawn from a population of 276 and a variance of 81, what's the probability that the mean of the sample will be less than 273? We can start this the same way, because we know that we want to know less than, so we don't have to worry about the 1 minus. Norm dist. My number is 273. My mean is 276. My standard deviation is, wait, I don't have standard deviation. I have variance. So to get my standard deviation, I have to take the square root of the variance. So I have to say square root of 81. You could have just plugged in 9 if you wanted to. Divided by the square root of n, which in this case is 40. Comma, true. This is what you need to solve to get your information, to get your answer. Let's copy this, and I'll put it on my list of work. Keep on going down, and I'll retype it. Norm dist of 273 at 276, 9 divided by square root of 40. Getting bit by mosquitoes out here. Comma, true. Alright, enter. 0.0175. So my answer here is 0.0175. Okay. Next question. Have some turkeys. Okay. They have a mean of 15.6, standard deviation of 4. Lifted 45 turkeys. What's the probability that their average weight is less than 14.5? We guys know the drill now. Less than means I can use norm dist. 14.5 is my cutoff. I have a mean of 15.6. I have a standard deviation of 4 divided by the square root of 45. Oops. Comma, true. Equals something. Copy this guy. Go back to Excel. Put them in. Equals norm dist of 14.5, 15.6, 4 divided by square root of 45, comma, true. 14.5, 15.6, 4 over square root of 45, true. We get 0.0325. Go back here, and your answer is 0.0325. The final one. Average score in some instructor exam. I have my mean, have my standard deviation. I'm looking at 50 scores with the average of at least 80. At least means that I need 80 or more, which means I have to do 1 minus norm dist. The mean is 75. My number is 80. Standard deviation is 12. The standard error is 12 divided by the square root of 50, comma, true. We know that that's what we need. So we'll copy this guy, go back to our Excel, put him in. 1 minus norm dist 80, 75, 12 divided by square root of 50, true. And you will get 0.0016. 0.0016. And that is how you would use the central limit theorem using technology to solve these normal distribution questions. That's it for me. I'll talk to you guys later. See ya.